Every flawless wooden board you buy at Home Depot has a brutal backstory. It all begins deep in the forest with a high-stakes judgment call. We are talking about years of meticulous tracking just to mark a single mature giant for harvest, clearing space for the next generation. This is not clear-cutting, it is surgical forestry. To pull it off, loggers lean on absolute heavyweights, like the Stihl MS 500i, the world's first fuel-injected chainsaw that cuts like butter in any weather. And when speed is everything, the mighty TigerCat L870C rolls in, grabbing and dropping multi-ton trucks with terrifying precision. But hold on, dropping the tree is barely 1% of the battle. How do you haul these brutal wooden leviathans to the mill without destroying tens of thousands of dollars in saw blades? Stick around, because the next prep step is pure madness. Once those mammoth logs land at the mill, you cannot just slam them into the main saws. If you do, you will tear up millions of dollars in precision equipment in a heartbeat's time. That is why every single trunk gets dropped onto massive log decks first. Think of these log decks as the ultimate staging ground. They act as a massive buffer zone, feeding raw timber into the factory with relentless precision, so the production line never stops moving for a single second. Now comes the brutal part. Before any steel touches the wood, these logs need a serious beatdown to get cleaned up. Out in the forest, bark traps all kinds of nasty stuff like dirt, grit, gravel, and sharp rocks. If any of that debris hits a high-speed saw blade, it will dull or snap the teeth in a matter of seconds. Enter the Rabber WD-1400 debarker. This beast strips away that rough outer layer like peeling an apple, leaving behind bare, exposed timber. But wait, clean bark is only half the battle. Deep inside these giant trunks lies an even deadlier threat. We are talking about old iron nails, fencing staples, or even leftover shrapnel buried deep inside the wood grain from decades ago. To stop a total catastrophe, the logs roll directly through a high-tech industrial metal detector. The system blasts a complete scan through the entire log, flagging any hidden metal before it can shred a $50,000 blade into flying scrap steel.
We'll put it at 10.
Once a log passes that grueling inspection, it is finally clean, safe, and ready for action. But this is where the real mind-bending science kicks in. How do you carve up a massive, uneven log to get the maximum amount of flawless lumber out of it without wasting a single inch? That life-or-death decision now falls entirely on a grid of intense laser beams and raw computer processing power. This is where we step into the absolute heart of the mill, where raw power meets crazy high-tech precision. The goal here sounds simple enough: squeeze every single usable inch of lumber out of a round log. But in reality, it is a high-stakes guessing game that no human eye can win. That is where best opening face laser technology comes in. Before a saw even touches the wood, 3D laser scanners map the entire surface of the log, capturing every curve, knot, and flaw. In milliseconds, a computer runs thousands of calculations to figure out the exact angle for that first critical cut, guaranteeing the mill gets the maximum amount of high-grade boards out of that single trunk. Once the strategy is locked in, the log gets shoved into the heavy machinery at terrifying speeds. This is where double-shaft gang saws do the heavy lifting. Instead of one blade taking all the punishment, two shafts split the cutting force right down the middle. That simple engineering trick eliminates vibration, keeps the saw running cool, and delivers razor-sharp accuracy even when ripping through the thickest, toughest logs you can throw at it. Right alongside them are ultra-thin bandsaws, engineered specifically to slice through wood while creating as little sawdust as possible. Less sawdust means more actual wood stays on the board, pumping up yield and saving big money over time. When those boards fly out the other side, they look bright, smooth, and ready to go. But do not get fooled by appearances. These freshly cut boards are completely green, loaded with trapped water and moisture. If you tried to frame a house or build furniture with them right now, they would twist, bow, and crack wide open within weeks as they dry out. So, how do you turn these fragile, waterlogged planks into rock-solid lumber that can stand strong for over a century? The answer lies in a brutal conditioning process that comes next. To survive decades of real-world wear and tear, those green boards need to go through a rigorous refinement process. First up is clean trimming. Rough edges are stripped away on the fly using the Optim KO 6 edging system. It scans the unique profile of every single board, instantly calculating the widest possible yield, and zips through to trim off uneven edges with zero hesitation. From there, industrial planers take over, smoothing the rough faces down to a satiny, touch-worthy finish. Now comes the ultimate crucible, kiln drying. Freshly cut lumber is packed tight with moisture, making it a prime target for warping, twisting, and rot if left unchecked. To fix this, huge stacks of wood are locked inside massive commercial kilns to bake out that excess water. For species like southern pine, the target is dropping moisture levels below 19%. This locks in structural integrity and guarantees those boards will never shrink or buckle once they are nailed into a frame. Keeping those huge kilns running takes a massive amount of power, which is why top-tier mills rely on high-efficiency ABB Syn-RM motors. These advanced drives circulate hot air non-stop through the chamber, keeping temperatures perfectly uniform while dialing down power consumption. By the time the wood emerges, it has hit the ultimate gold standard for construction lumber. But here is the catch that keeps mill managers up at night. What happens to all the leftover wood scraps, ugly offcuts, and small timber that are too short or weirdly shaped to make standard 2x4s? Throwing them away would mean tossing serious money down the drain. The solution lies in an insane engineering trick that turns worthless wood waste into structural beasts that are actually stronger than natural timber. Instead of tossing out those small, awkward logs or scrap ends, the mill puts them through a high-tech transformation that outperforms solid wood. This is where engineered wood comes into play. Small diameter logs that would normally be useless for solid timber are sliced down into razor-thin sheets of veneer. These thin layers get coated with heavy-duty adhesives, stacked together with their grain aligned, and blasted with extreme heat and pressure. The result is laminated veneer lumber, or LVL. These LVL beams are absolute powerhouses, carrying massive structural loads across wide spans for roofs and floors without sagging or twisting like natural timber often does. Then you have all those short, leftover wooden offcuts that seem useless. Instead of letting them go to waste, the mill runs them through a finger jointing system. Automated saws chop out any knots or weak spots, then carve interlocking finger-like teeth into the ends of each clean block. After applying high-strength glue, these pieces are smashed together under incredible hydraulic force. What you end up with is a continuous, ultra-long board that matches or even beats the strength of solid lumber. At this point, it looks like every single piece of timber has been squeezed for maximum value. But what about all the leftover bark stripped off at the start, the endless piles of wood chips, and the clouds of sawdust floating around the factory floor? Throwing all that waste into a landfill would be environmental disaster and a massive money loser. That brings us to the final mind-blowing piece of the puzzle. A closed-loop system where nothing goes to waste, and the mill literally powers itself. In a modern mill, the concept of waste simply does not exist. Every piece of bark and scrap wood gets shredded into hog fuel to fire up massive boilers, creating heat for the drying kilns. Clean wood chips head straight to paper mills, while fine sawdust becomes cozy bedding for livestock. On top of that, advanced ABB regenerative drives capture power every time heavy machinery slows down, slashing energy consumption by 40%. Looking at this process, there is a powerful lesson for us all. Nothing in life is truly wasted unless we choose to throw it away. Even our toughest challenges and leftover mistakes can be repurposed into energy and strength for what comes next. True success happens when we honor raw natural potential and refine it with patience and smart technology. If this journey inspired you, smash that like button, leave a comment below with your thoughts, and subscribe for more amazing deep dives.